In this lesson, we are going to go over hyperbolas, which is the third shape of our conic sections. So from your formula sheet, we have now gone over circles. We have gone over ellipse. And so circles happen when you slice those two cones perpendicular to the base. An ellipse happens when you still stay in either the top or the bottom of the two cones, but you go diagonally. So then you get an ellipse, which is like an oval. And then now we're going to go over a hyperbola. So that's when you slice it kind of going through from top to bottom. So hyperbola for today. So here's our general shape of a hyperbola. And here's the definition. So we'll start with the definition. The definition of a hyperbola is the collection of all points in a plane, the difference of whose distances from two fixed points called foci is a constant. So before, when we had an ellipse, excuse me, before when we had an ellipse, it was very similar to this. But instead of a difference in an ellipse, it's the sum. So now that I have a hyperbola, it's whose difference of two distances from the fixed point, the foci, is constant. So if we just pick some point on this hyperbola, and that hyperbola are these two blue shapes that kind of look like parabolas facing away from each other. If you pick some point on that hyperbola and you connect that point to one focus, and we'll call this D1, and you connect this point to your second focus, and we'll call this D2, then that fixed point would say D1 minus D2 is going to equal either plus or minus 2a. Some textbooks will say the absolute value of 2a. And so no matter where that point is on that parabola, even if or on the hyperbola, even if it's down here, and you connect this point to here, and then you connect this point to here, and you subtract the two, you get the exact same number. So no matter where that point is, you're always going to get that 2 number when you subtract. So again, that's not super important, but that is what the definition is stating. Now, I'm going to go ahead and erase this so we can talk a little bit more about this shape before we start getting into this. So my hyperbola are these two blue shapes, and they look like hyperbolas that are facing away from each other, or parabolas, goodness gracious. They look like parabolas that are facing away from each other. So these two together is your hyperbola. So you have something called the transverse axis, and so the transverse axis will contain both of your foci and your vertices. And then you have something called the conjugate axis, and so that's perpendicular to your transverse. We don't pay a lot of attention to it, but that conjugate axis would have also kind of two vertices here. Now, as you can see, that's not part of my graph, but what you will do, if you remember from ellipses, your major vertices, okay, and in this case, really your only vertices are on your transverse axis, and we label these A. This is what my B is, and so what we will end up doing is kind of making this imaginary box. And then from that imaginary box, we will make two asymptotes from there. And that's how we'll know what shape these hyperbolas make, how wide they are or how skinny they are. So we'll use our A and our B to kind of make a box, and then we will draw our asymptotes through it. And then that's how we'll know how to make that shape. And then the other thing I want to make a point of is referring back to our ellipse. We had our two major vertices. And then we had our minor vertices. So again, that's my A and my B. Okay, but inside here, this is where my two foci were inside my ellipse. When you look at your hyperbola, your vertex is inside your foci. Now your foci are outside of where your hyperbola or of your vertex. So that's something that's changing places. Here your vertex were on the outside. Here now my foci are on the outside. Okay, so that's your introduction to hyperbolas.